So in this case, we are going to continue with our matrices working with the inverse matrix. We saw that from the previous class that we had, we can determine the determinant of a 2 by 2 matrix. So it is the same condition of an inverse matrix. It is taken from a 2 by 2 matrix, all right? From a 2 by 2 matrix. So this one, it is a continuation of what we had from the determinant, okay? So given the matrix A being a 2 by 2 matrix A, B, C, D, like this, it follows that the inverse of a matrix, which can be written as A to the exponent of -1 for the notation, right? So this is the notation that you can use for the inverse to the power of what? -1. So A to the power of -1 is going to be written as 1 over the determinant of A. So you consider the determinant of A. All right. So it's 1 over the determinant of A. Then what happens is that you interchange elements in the major diagonal. You swap them. You interchange. So swap the major diagonal. You swap those elements. So this will be D and this will be A. The minor, this one, the minor diagonal, you multiply by negative. So multiply by negative the what? The minor diagonal. So the minor diagonal, you multiply by a negative. So it's going to be negative B, negative what? Negative C. This is the inverse of a 2 by 2 matrix. But remember how you calculated the determinant. You say the determinant is equal to what? AD minus BC. So you can just put that into consideration that the inverse is going to be 1 over determinant of A, which is AD minus what? AD minus BC into what? This part that we had here. So that is what you are going to use as the inverse. So the inverse is a continuation from the determinant. You need what? The determinant first. And this inverse is for a what? The inverse matrix from a 2 by 2 non-singular matrix. This 2 by 2 matrix that we're talking about, it's a what? It's a non-singular matrix. All right. For a singular, when you are given a singular matrix, it has no inverse. This one has no inverse. So simply means if there is no inverse, it simply means the determinant is 0. Remember, we talked about that. Since determinant is what? 0. We cannot have 1 over 0 in mathematics. 1 over 0 of whatever. 1 over 0 does not exist. So that's why we say the singular matrix, it does not have an inverse. It is because of that 1 over 0 concept. All right. So that is what you're simply going to need for determining of the determinant and inverse in calculations. All right. So let us just consider just one or two as examples. As we can see, this is just a continuation from what we had. So I'm just going to quickly have this from our calculations. All right. Let's say we are to determine the inverse. All right. Find the inverse of A. Find the inverse of what? Of A. If our matrix A is equal to -3, 0, -2, 5. Like this, all right? So like I said, the inverse is simply what? 1 over the determinant. So you need the determinant first of what? Matrix A, all right? So let's find the determinant first of what? matrix A, which we said determinant from the major diagonal minus what? The minor diagonal. AD minus what? From the AD minus BC concept. So that's the major diagonal. This one minus 3 times what? Times 5. That's our major diagonal. You multiply minus 3 times 5, then subtract the minor diagonal, 0 versus what? 0 versus minus 2. That's 0 times negative 2. All right, so that's our determinant here. Minus 3 times 5, that's minus 15. Minus, what are we subtracting? 0 times minus 2. Any number times 0, that's what? That's a 0 here. So here we're just going to obtain what? A 0. So minus 15 minus 0, that's what? That's minus 15. This is our determinant. So the inverse now, this was our determinant, remember? So we are now on the what? On the inverse, a to the power of minus 1. It is 1 over the determinant, 1 over determinant from here, 1 over the determinant. Then what happens? We saw that in the major diagonal, you swap the major diagonal, multiply by negative the minor diagonal. So the major diagonal, you simply swap them. This was our major diagonal, all right? That's our major. You swap, all right? So you simply swap these two. So it's going to be 5 here, minus 3 here. The minor diagonal multiply by what? Negative. The minor diagonal, minus times 0. That's a 0. Minus times minus 2. This minus 2. You multiply it by a negative. Minus times minus, that's what? A positive 2. So that's the concept. So here we can rewrite properly. The inverse is going to be, we take the negative up or just along this division line, or you write it on top. So that's minus 1 over what? Over 15 into this. All right, so that's 5, 0, 2, minus 3. So that will be the inverse of what? Of the given matrix, just like that. So this is the application of the inverse, all right, from a 2 by 2. So I want you guys to work out as many questions as you can on the inverse of what? Of a 2 by 2 matrix. And remember, we talked about some properties before, which was an identity matrix, and we said it is obtained from the inverse to its original matrix. Let us just prove that, because we are going to use it when solving simultaneous equations. And on that part, I'm not going to explain a lot of things, guys. We see that we are going to need it in solving what? Simultaneous linear equations. So let's talk about this now, because on that class, guys, I'm not going to refer it. I'm just going to tell you guys, we talked about this. You remember that class, like that, so that we do finish this syllabus, all right? So this is it, and we just want to prove that truly the inverse and the original matrix is going to give us what? Identity matrix, which is 1, 0, 0, 1. Okay, let's prove that. Okay, let's prove that. This is the inverse that we have here. Minus 1 over 15, 5, 2, 0, minus 3. That is the inverse of what? Of matrix A. Then the matrix A is this one originally given. So we're going to take our matrix A originally given. Matrix A was negative 3, 0, negative 2, 5, like this, okay? So let us prove that we are going to obtain that matrix. So minus 1 over 15, we're just going to treat it as a scalar. So let us just properly multiply our matrices as we do understand row by what? By column, all right? Concept. So you're going to consider this a 2 by 2, and multiplying a 2 by 2, it is possible, yes, and the answer is going to be a 2 by 2. So let's multiply 5 times what? Negative 3. That's negative 15. 0 and what? Negative 2. That's a 0 you add. Remember, you add there. So you multiply to this second column, 5 times 0, that's a 0, all right, plus 0 times 5, that's what? That's a 0, right? So it's 5 versus 0 and 0 versus 5. So this is it. Okay, so that was on that row and that column. Then the second row, all right? So you're gonna consider the second row to the first column, 2 and what? -3. 2 times -3, that's -6, plus -3 and -2, that's gonna be a +6. -3 times -2, that's a +6. All right. So this one was simply going to be a +6. There's no need of a bracket. All right. Then 2 times what? All right. Let's move on to the other. We are on this column now. 2 is multiplying what? The 0 there. All right. So 2 times 0 here, that's what? That's a 0. All right. Then -3 multiplies what? The 5 here. This one. -3 times 5, which is what? -15. -15. So let's combine with the -1/15 outside and see what's going to happen. All right, -15 plus 0, that's -15. 0 plus 0, that's a 0 here. -6 plus 6, that's a 0. 0 plus -15, a plus and minus, that's a minus. So 0 minus 15, that's what? -15. Multiplying by the -1/15 outside of the matrix each term as a scalar, it is going to be -1/15 times what? 15 -1/15 times -15. So this cancels, you obtain -1 times -1, which is +1. Any number times 0, that's what? That's a 0. Any number times 0, that's what? That's a 0. Are we seeing that here it is the same -15 as before? So it is going to give us what? A 1. So that is exactly an identity matrix that we are having here. Identity what? Matrix. So we have proved that once you multiply the inverse of a 2 by 2 matrix to its original matrix, you obtain what? An identity matrix. So be very careful about that and be prepared to use that in solving simultaneous equations using the same concept. So I'm just gonna refer a basic, then you work out as many question papers from this idea that you have. Please apply it to answer question papers. They can give us certain statements, a lot of things that you have to consider practically and so on. So do revise. That can help, all right? That can help in your preparations, But for now, that is it. That is it for now. Till we meet again.